Welcome to Tech Girl Kannada YouTube channel. Data structures, classifications, primitive and non-primitive data structures, operations, review of array structures, self-referential structures, union pointers, dynamic array, memory allocation functions, representation of linear array in memory, dynamically allocated arrays, array operations, traversing, inserting, deleting, searching, sorting, multidimensional arrays, polynomial sparse matrix, then strings, basic terminologies, string operation, pattern matching, algorithms, programming examples, and everything. Data, values or set of values. Data item refers in a single unit of value. Data items, sub items that are not group items, elementary items. Collection of data are frequently organized into a hierarchy of fields, records, and files. An entity is something that has certain attributes or properties which may be assigned values. Values may be numeric or non numeric. Entity, employee, attributes, name, age, USN, values, RAM, 35, 123. Entities with similar attributes form an entity set. Field is a single entity, elementary unit of information representing an attribute of an same entity. A record is a collection of field values of a given entity. File is the collection of records of the entities in a given entity set. Each record in a file may contain many field items, but the values in a certain field may uniquely determined in the record in the file. Records classified according to length, fixed length records, variable length records. There are fixed length records. All the records contain the same data items with the some amount of space assigned to each data item. Variable length records, file records may contain different lengths. It has a minimum and a maximum length. Data structure data may be organized in a different many ways. The logical or mathematical model of a particular organization of data is called data structure. The logical or mathematical model of a particular organization of the data is called data structure. Note this point, guys. Examples of data structure are arrays, linked list, stack, queue, etc. Data structures are widely used in every aspect of computer science, operating system, compiler design, artificial intelligence, graphics, and many more. Types of data structure are primitive, non-primitive, linear, non-linear. Primitive data structures are the basic data structure that are directly operated upon the instruction. Integer, float, characters, pointers are examples of primitive. Integer is a data type, whole numbers. Float is a data type storing the fraction numbers. Character is a data type. Character values pointer a variable that holds the address of the another pointer, another variable. The non-primitive data structures emphasizes the structuring group of the homogeneous or heterogeneous data items. Example of non-primitive data types are arrays, lists to files, etc. An array is a fixed size sequenced collection of elements of the same data type. List, an ordered set containing variable number of elements. It is collection of logically related information. Files, it can be viewed as large list of records consisting of variable fields. Then linear data structure, it is a kind of data structure that has a homogeneous elements. Data structure in which elements are in the sequence and form a linear series. Easy to implement since the memory of the computer is also organized in a linear fashion. stack, queue, linked list, etc. Nonlinear data structure is a data structure in which data item is connected to several other data items, exhibit either a hierarchical relationships or a parent-child relationships. Data elements are not arranged in a sequential structure that has trees and graphs. Arrays, linear arrays or one-dimensional array, list of a finite number n of similar data elements k. In A of k called a subscript, A of k called subscripted variable. Linear array, each element is referenced by one subscript, that is student 1, John, 2, Ram, 3, Sam, 4, Gold, Mary. Student of 2 denotes Ram. Two-dimensional array is a collection of similar data elements where each element is referenced by two subscripts. There are 5 stores. Each store have 5 departments. There is store and sales. Sales of 2, 3 will be 325. Size of the array is 5 cross 4. Then stack is called a last and first out system in a linear list in which insertion and deletion can take place only at one end of called top. Dishes on a spring system. Queue, called the first in first out system, is a linear list in which deletions can take place only at one end of the list and the front of the list, and insertion can take place only the other end of the list, that is rear of the list. A line of people waiting at a bus stop. Linked list, to maintain a file where each record contains a customer's name and his or her salesperson. Linked list, store in a table form. Note a good way to store the data. Adam, Smith, Brown, Ray, Clank, John, David, Ray, Farid, Smith. Another way, separate array for a salesperson and an entry pointer, the customer file, which gives the location of each person's salesperson, like this. Integer used as a pointer requires less space than the name. This representation saves space. If the company wants the list of customers for a given salesperson, search through the entire customer list. Salesperson pointer have a set of pointers giving the positions of his or her customer's salesperson. Linked lists. Definition, representation of the linked lists in memory. Allocation, garbage collection, linked list, operation, traversing, searching, insertion, and deletion. W linked lists, circular linked lists, and header linked lists, linked stacks and queues. Application of linked lists, polynomial, sparse metric representation, programming examples. Simple data structure, successive nodes of the data objects were stored at fixed distance apart. Insertion requires us to move elements already in the list, either one location higher or lower. Deletion, move many elements so as to maintain the sequential representation by the list. Solution to the problem data movement in sequential representation is achieved by linked representation. In linked representation, these items may be placed anywhere in the memory. List refers to a linear collection of data items. Data processing frequently involves storing and processing data organized into the lists. Store the data by means of arrays. Linear relationships between the data elements of an array is reflected by the physical relationships of the data in memory. Not be any information contained in the data elements themselves. Easy to complete that address of an element in an array. Array usually occupies a block of memory space. One cannot simply double or triple the size of an array when additional space is required. Another way of storing a list in memory is to have each element in the list contain a field called a link or pointer, which contains the address of the next element in the list. Successive elements in the list need not occupy the adjacent space in the memory, makes it easier to insert and delete elements in the list. Searching through data for inserting and deleting, as in word processing, not store the data in an array. Use list using pointers. This type of data structure is called linked list. A linked list or one-way list is a linear collection of data elements called a node, where the linear order is given by means of pointers. A link field node is the link field, or the next pointer field contains the address of the next node in the list. Then information part contains the entire record of data items, name, address, everything. The pointer of the last node contains the special value called the null pointer, which is any invalid address. This null indicates the address end of the list. Linked list contains a list pointer variable called start. This contains the address of the first node in the list. Need only this address in start to trace through the list. Start null. The list that has no nodes are called null list or empty list, denoted by null pointer in the variable start. Each has a 0 or more data fields, one or more link or pointer fields. Representation of the linked list in the memory. List be a linked list. List will be maintained in memory unless otherwise specified or implied. List requires 2 lines anyway. Information of k, that is information part. Link of k, next pointer field of a node of the list. List requires a variable name start, contains the location of the beginning of the list. The nodes of the list need not occupy adjacent elements in the array info and link. More than one list may be maintained in the same linear array info and link. Each list must have its own pointer variable given the location of the first node. Example, a linked list in memory where each node of the list contains a single character is. Then comes to this, that is information is n, then the next field is 4, information is t, then the next field is 0, 6, then the information is 6, then space, then the 11, then it goes to e, then it is 7 is x, no exit. Example 2, two lists of test scores DSA and ADE maintained in memory. The nodes of both lists are stored in the same linear array. Test and link names of the list are also used as the list pointer variable, like this, DS and ADE. Then example 3 is 4 brokers. Each broker has its own list of customers. Broker pointer to this. Ram is Gomati, Sunil, Vivek, Kiran are the customers. Then a null pointer 0 appears in the point 3. That's it. All 4 lists of customers appears in the same array. Customer and an array link contains the next pointer fields of the nodes of the list. Array bro contains the list of the brokers and the pointer array point such that point of k points to the beginning of the list of the customers of broker of k. Example 4, the data must be stored in the same type of record structure or in the collection of parallel array. Information part of the node may be a record with more than one data. Personal file of a small company contains the data such as name, USN, gender, salary, normally for parallel arrays. It is like this that shows how the data stored in as a sorted list, linked list using only one additional array link. For the next pointer field of a list and the variables start to point to the first record in the list. Then the memory allocation. Maintenance of the linked list in memory assumes the possibility of inserting new nodes into the list, and here the hence the require some mechanism which provides unused memory space for the new data, new nodes. Some mechanism is required where the memory space of deleted node becomes available for the future use. A special list is maintained which consists of unused memory cells. This list has its own pointer called list of available space or free storage list or free pool. Unused memory cells in the array will also be linked together to form a linked list using a val as its list pointer variable. Such a data structure will frequently be denoted by writing list info link start aval start equal to null. List is empty. Each of the lists may use the aval list. Garbage collection. Some memory space become reusable when the node is deleted from a list. Entire list is deleted from the program. Want the space to be available for the future use. One way is to reinsert the space into the free storage list. Do it while implement the linked list. Time consuming for the OS of the computer. The OS of the computer periodically collects all the deleted space onto the free storage list. Technique which does this collection called garbage collection. Garbage collection takes place in two steps. Computer runs through all the lists, tagging those or cells which are currently in use. Then computer runs to the memory, collecting all untagged spaces onto the free storage list. Garbage collection may take place when there is only some minimum amount of space or no space at all left in the free storage list, or when the CPU is idle and has time to do the collection. Garbage collection is invisible to the program. Overflow and underflow. Data to be inserted into the data structure, but there is no available space. The free storage list is empty, called overflow. Program modify the program by adding space to the underlying arrays. Overflow will occur with our linked list when while equals to null. There is an insertion. The term underflow refers to the situation where one wants to delete data from the data structure that is empty. Underflow will occur with the linked list when stat equals to null. There is a deletion. List is a dynamic data structure. The number of nodes on a list may vary dynamically as elements are inserted and removed. Create a list. Manipulate the list. To create a list require nodes where the required number of nodes are present. Available list. How to get this get node? When nodes are not required, how to return back free node. List. The free memory space available which is not used by any program is considered a pool of empty nodes. Since free memory space is finite have a finite pool of empty node. The list of free available nodes are called available list. The avail of this null will be empty available list. The node in the available list cannot be accessed by the programmer directly. Using get nodes and free nodes, the user can access the available list. If avail equal to null, then print out of memory, return null. If p equals to avail, then avail equals to link of avail, return p. Get node is a function which removes the first node from the available list and makes it available for the user. Each time get node is invoked, it gives a new node from the available list. Once a node is obtained from the available list, we can use this node to store information. Node p is equals to get node declares a pointer p is equals to get node. This function get node is implemented based on whether the available list is empty or not. Use malloc to allocate memory explicitly as and when required and exact amount needed during execution. The prototype of malloc is defined in a header file strlib.h. Then node get node x equals to node malloc size of struct node. Then if x equals to null, free node not exists. Printf out of memory, exit of 0, terminate, return x. Then the size is applied to the structure type and returns the number of bytes required for the entire structure. Free node is a function which returns unused node to the available list. The node thus returned is added to the beginning of the available list. Free node of p variable p points to the node is no longer used, so it is required to return this node back to the available list after executing free node. The node pointed to by p is returned to the available list. Now pointer p doesn't contain valid address, now it is a dangling pointer. Return node added to the beginning of the available link should contain address of the first node of the available list and link of p equals to available. Make the new return as the starting address of the available list. Avail equals to p. Free node of p is link of p equals to avail. Avail is equals to p. Self-referential structure. The nodes in the linked list are self-referential structure. That is, if the type of member in the structure is same as the header of the structure definition identified by struct tag name. If the type of a member in the structure is same as the header of the structure definition, that is called self-referential structure. That is struct node int info struct node of link. A link is a pointer to the list structure and type of a pointer link is struct node. Type def struct node as a pointer to the struct node. Way of defining the structure. A self-referential structure is a structure which has at least one field which is a pointer to the structure. The value of link is either the address in the memory of an instance of list or the null pointer. Pointer variable start can be declared as node start or struct node first. There are different types of linked list: singly linked list, doubly linked list, circular singly linked list, circular doubly linked list. Traversing of the linked list. Traverse list in order to process each node exactly once. Algorithm was pointer variable pointer which points to the node is currently being processed. link of pointer points to the next node to the processed. PTR is the link of pointer move to the pointer to the next node in the list. Traversing a linked list. Set PTR at start. Repeat 3 and 4 while pointer not equal to null. Apply process to infer PTR. Infer of PTR. Set PTR equals to link of PTR. End of step 2. To print the information of this. Here is the variable pointer points to the current node, then it goes to PTR equals to link of PTR. Find the number of elements in the linked list. Count info, comma, link, comma, start, comma, num. Set num equals to 0. Then PTR equals to start. Repeat step 4 and 5 while PTR not equal to null. Set num is equals to num plus 1. Set PTR equals to link of PTR. Then end of step 3. Return. Searching a linked list. Searching algorithm finding the location B of the node where item first appears in the list. Sorted list and sorted list. List in sorted. Search info link start item location. Then set PTR equals to start. Repeat step 3 while PTR not equal to null. If item is greater than the info of PTR, then seek PTR equals to link of PTR. Else if item equals to information of PTR, then loc equals to PTR and exit. Else set loc equals to null and exit. Exit of if. Exit of step 2 step. Then set loc equals to null, exit. Then unsorted list. We have search of information, link, start, item and location. Set PTR to start. Repeat step 3 while PTR not equal to null. Item equals to information of PTR, then loc equals to PTR. Else set PTR to link of PTR. PTR to link of PTR. That's it. End of if. End of step 2. Set loc equals to null, exit. Example. Reads the SSN 101 of an employer, then gives the employer 5% increase in the salary. Read 101 call search of SSN link start 101 loc. If location not equal to null, then set salary of loc equals to salary of loc plus 0.05 into salary of loc. Else write 101 is not in the file. End of if. Return. Apply binary search algorithm for sorted array. Binary search algorithm cannot be applied for sorted linked list since there is no way of indexing the middle element of the list. This is the drawback of using the linked list as a DS. Void search, key node start, node PTR, start equals to null, then link list is empty. Return. PTR equals to start while PTR not equal to null. If key equal to pointer info, then break it. PTR equals to PTR link. If PTR equal to null, search unsuccessful. Return. Search successful. Then insertion into the linked list. Insert a node at the beginning of the list. That is, insert front. Info link start a while item. For while equal to null, then write overflow and exit. Set new a while equals to link of a while. Set info of new equals to item. Set link of new equals to start. Set start equals to new. Node insert front of int item node start. Node new equals to get node. New info equals to item. New link equals to start. Then start equals to new, the return start. Then insert a node at the rear end. That is, insert rear int item node start. Node equals to new node ptr. New equals to get node. Then new info equals to item. New link equals to null. Then if start equal to null, return new. ptr equals to start. While ptr link not equal to null, ptr equals to ptr link. Then ptr link equals to new, return start. Then inserting into a sorted linked list. Information of A is less than item, then information is less than or equal to information of B. Finds the location lock of the last node in the list whose value is less than the item. While traversing, keep track of the location of the preceding node by using a pointer variable. Save. That will be given as in the program node insert in order of int item comma node start node new save ptr new equals to get node new info is item new link is null because we are inserting where we are inserting we don't know that. So then if start equal to null, return new. Then if item is less than or equal to start info, then we have to insert it front. So new link equals to start, then return new. If not, then save null. Save equals to null. ptr equals to start, while ptr not equal to null, and item is greater than ptr info. ptr not equal to null and ptr item is greater than ptr info. Save equals to ptr equals to ptr link. It goes on. Save link equals to new, then new link equals to ptr, then return the start. This is what happens. And diagrammatically we represent like that. Then list be a linked list with the successive nodes A and B. Node new is to be inserted into the list between node A and B. Data list, first storage list. 3 pointer fields are changed here. A while should come to the next position, then previous position is also available. 3 pointer fields are changed. Next pointer field of A now points to the new node. Then a while now pointer points to the second node in the free pool. Then the next pointer field of node new now points to the node B. Special case if the new node is new is the first node to the list, then start will point to the new itself. If the new is the last node in the list, then new will contain the null pointer. Inserting after the given node. Insert lock. Disadvantage: each salesperson may have many pointers, and a set of pointers will change as customers are added and deleted. Popular way: each salesperson has one pointer which points to his or her first customer, whose pointer in turn points to the second customer, and so on with the salesperson's last customer indicated by null value. Customer link salesperson will be like this. This is an example of linked list. Easily obtain the entire list of customers for given salesperson. Pointer: when an element is in one list points to an element in a different list. Link: when an element in a list points to an element in the same list. Pointer and the link. Pointer, that is points to an element in a different list. Okay, that's the difference between pointer and the link. Trees. Data frequently contain a hierarchical relationship between various elements. Employee, SSN, name, address, sales, name, last name, first name, then address, street, area, city, state, zip, then the salary. Algebraic expression will be like 2x plus y, then a minus 7b whole cube. Graph. Data sometimes contain a relationship between pairs of elements, which is not necessarily hierarchical in nature. Airlines lies only between the cities connected by lines. Data structure operations. Data appearing in the data structure are processed by means of certain operations, accessing each record exactly once so that certain items in the record may be processed. Accessing and processing, sometimes called visiting the record. Searching, finding the location of the record with the given key value, or finding the location of all records which satisfy one or more conditions. Inserting, adding a new record to the structure. Deleting, removing a record from the structure. Sorting, arranging the records in some logical order. Merging, combining the records in two different sorted files into a single sorted file. Pointers and dynamic memory allocation. The actual value of a pointer type is an address of memory. Two important operators used with the pointer type: ampersand address operator. Dereferencing or indirection operator is this star declaration enti pointer pi. Then I is the integer variable, pi is the pointer to an integer. Pi is ampersand of I. Then ampersand of I returns the address of I and assigns it to the value pi. To assign a value to I equals to 10, ampersand pi equals to 10, null pointer points to an no object or function. Null pointer is represented by the integer 0. Pointer is a derived data type whose value is the address of the memory location. Pointer variable which holds the address of another variable. Pointer variable always point to the corresponding type of data. Float AB. int x pointer p is ampersand a, b equals to pointer p. Wrong. Trying to assign the address of a float variable to an integer pointer. It will never occur. Value of the pointer ptr4104 value, it points to is 10. X is equals to pointer of 8x, then pointer ptr equals to y, 8x minus 8 into ptr. So int x y, int pointer ptr, x equals to 10, ptr minus equals to 8x, then this will be occurring. ptr is 14104. That will be 8 into this ptr. Value of the pointer is this. Then ptr 25, then it will print the ptr as 25. Determine if one pointer is greater than or less than or equal to another. Convert pointers explicitly to integers. Other operations. Assign a pointer to a variable of type pointer. C allows to perform arithmetic operations such as addition, subtraction, multiplication, and division on pointer. Dynamic memory allocation. Memory can be allocated for variables using two techniques. Static allocation uses declaration and definitions. Dynamic allocation using predefined functions. Static allocation. If memory space is allocated for various variables during compilation time itself, the allocated memory space cannot be expanded to accommodate more data or cannot be reduced to accommodate less data. Once the size of the memory space is allocated is fixed, it cannot be altered during execution time. This method of allocating the memory during compilation time called static memory allocation arrays. Dynamic memory allocation is the process of allocating the memory during the execution time or runtime. Memory management function used for allocating and freeing memory during program execution is malloc, calloc, realloc, and free. Malloc allocates request size of bytes and returns pointer to the first byte of the allocated space. Allocate requested size of bytes returns a pointer to the first byte of the allocated space. Calloc allocates space for an array of elements, initializes them from 0, and then returns a pointer to the memory. Realloc modifies the size of previously allotted space when requested memory is not available. The pointer null is returned. Frees previously allocated space, deallocates an area of memory previously allocated by malloc. This function allows the program to allocate memory explicitly as and when required, and the exact amount needed during execution. Allocates a block of memory. Size of the block is the number of bytes specified in the parameter. Hash include strlib.h, ptr is equals to data type star malloc n into size of data type. typedef expression transform the resulting pointer into a pointer of the correct type. The pointer assign it to the proper pointer variable. PTR is a pointer variable of type data type. Calloc, contiguous allocation of memory blocks. Memory blocks having consecutive addresses, each of same size, and then initializes the allocated memory to 0. All allocated bits are set to 0. A pointer to the start of the allocated memory is returned. In case there is insufficient memory to make the allocation, the return value will be null. Pointer PTR cast type star calloc n comma element size. N is the number of blocks to be allocated. Element size the number of bytes in each block. Cast type. Then realloc, change the memory side already allocated with the help of the realloc function. When realloc is able to do the resizing, it returns a pointer to the start of the new block. When it is unable to do the resizing, the old block is unchanged and the function returns the value null. New memory block may or may not begin at the start place as the old one. PTR is equals to realloc PTR comma new size. Realloc PTR comma new size. Reallocating the memory will not destroy the original contents of the memory. Free. No longer need an area of memory. Free it by calling another function free. Return the area of memory to the system. Free PTR. After freeing the memory, the pointer value stored in the PTR is not changed. It still contains the address of the first byte of the memory block allocated earlier. Using the pointer PTR, even after the memory has been released, error. These logical errors are difficult to debug and correct it. So immediately after freeing the memory, it is better to initialize to null. Free PTR equals to null. Allocation and deallocation of the memory. Int I star p float f1 then star pf. Pi is equals to int malloc size of it. Pf is equals to float malloc size of float. Then pi is 1024. Pf is 3.14. Then an integer and the float value. Free pi, free pf. If we insert a line pf front malloc size of float immediately after the printf statement, then the pointer to the storage used to hold the value 3.14 has disappeared. Now there is no way to retrieve this information. This is an example of dangling reference. If we insert the line printf float malloc immediately after the printf statement, then the pointer to the storage used to hold the value 3.4 has disappeared. Now there is no way to retrieve the storage. That is the dangling reference. Then arrays can be used to represent a group of data items that belongs to the same type. Structure is a mechanism for packing data of different types. Structure should define first for their format, then declare structure variables. Struct tag name of the structure called structure tag. Then data type number 1, variables that are used to store the data called members of the structure fields of the structure. The structure definition has not declared any variables. It describes a format called template to represent information. Using definitions, no space is reserved once a declared memory space is reserved. Then, during definition, no space is reserved once a declared memory space is reserved. Declaration tagged structure, structure variable, type defined structure. Structure is for handling a group of logically related data items, can be accessed using variables, array, derived data type, structure, programmer defined. Tagged structure. Structure definition with tag name of the structure. Struct tag name, data type member 1, member 2, then struct student s1, s2, s3, variables of this type struct tag name. Then members of the structure themselves are not variables. It won't occupy any memory until they are associated with the structure variable. Size of the memory allocated is the sum of the size of the individual members. That is structure variable struct e2 a1 e2 not recommended without tag name, can't use it for future declaration. Type defined structure, type def struct, type member 1, member 2, type name. Then we can use it in anywhere in the program. Type name of the type defined by the structure definition. Follow this definition with declaration of the variables. Structure variables, user defined data type. Type def is a keyword that allows the programmer to create a new data type name for an existing data type. Then advanced, create meaningful data type. Name of the type defined by the structure definition. Followed this definition with the declaration of variables. Structure variables, user defined data type. Type def is a keyword that allows the programmer to create a new data type name for an existing data type. Advanced, like create meaningful data type names for increasing the readability of the program. Next, type def struct student. Structure definitions appears at the beginning of the program file before any variables or functions are defined. Also appear before the main along with the macro definitions such as hash define. In this case, definition is global and can be used by other functions as well. Accessing structure members. Members themselves are not variables. It should be linked to the structure variable in order to make it meaningful members. Link between a member and a variable is established using the member operator dot, called dot operator, or period operator. Dot operator is select a particular member of the structure a1 dot member 1, assign value to member of a1 dot member 1 is 100, a1 dot member 2 is 200. We scan to give the value through the keyboard. Scanf event.member like this. To initialize to structure variable, it is essential to use the tag name struct record student 1, struct record student 2. Initialize a structure variable outside the function. Then we have this main struct record student 2 is this compile time initialization. Even within this main function outside we can initialize, or just beside the struct we can initialize them anyway. Compile time initialization. Order of values enclosed in braces must match the members or in the structure definition. Allows partial initialization. Array of structures. Int marks. We have int marks student of 2 will be equal to something like this. Student of 1, student of 2 will give you the values as declares the student as an array of 3 elements, student of 0, student of 1, student of 2, and initializes their members as this dot sub 1, sub 1, sub 2, sub 3, subject 1. Then arrays within the structure, that is use of arrays as structure members, that will be like in float subject of 3, that is inside the structure. Member sub contains 3 elements. These elements are accessed using appropriate subscript. Student of 1 dot sub 2 refers to the marks obtained in the third subject by the second student's third subject. Structures within the structures. Struct salary, nesting of structure, char name, char dep, struct DA, HRA, allowance, employee, allowance, then employee. It is referred to by employee.allowance.da is what? Employee.allowance.hra is what? Employee.allowance of invalid actual member is missing. Employee.hra invalid because inner structure variable is missing. An inner structure have more than one variable. That can be like this. Allowance, or another one is arrears, which is like access the base member using employee dot allowance dot da, employee dot arrears dot da. Use tag names to define inner structure in da int hra. Then struct salary, char name, char department, then struct pay allowance, struct pay arrears are also exist. Unions. Syntax same as structure. Fields on the union must share their memory space. Only one field of the union is active at a given time. Union item may be intem, float, text, char C, and code is the union name. Declare a variable code of the type union type. Then accessing using the dot operator only. Use structures, unions, and arrays to create variables of large size. So use unary operators size q tells us the size of the structure, size of struct x. Highlight the number of bytes required to hold all the elements of the struct x. The internal implementation of the structure will be like this. Values will be stored in the same way using increasing address locations in the order specified in the structure definition. Holes or padding may actually occur within a structure to permit two consecutive components to be properly aligned within memory. The size of an object of a struct or union type is the amount of storage necessary to represent the largest component, including any padding that may be required. Structures must begin and end on the same type of memory boundary. For example, an even byte boundary or an addresses that is a multiple of 4, 8, or 16. Self-referential structures is one in which one or more of its components is a pointer to itself. It usually requires dynamic storage management routines, malloc, and free to explicitly obtain the release memory typed as struct list, char data, struct list link. Each instance of a structure list will have two components, data and the link. Data is a single character, link is the pointer to list structure itself. The value of the link is either the address in the memory of an instance of the list or the null pointer. Create three structures, item 1, item 2, and item 3. Each contain the data item ABC respectively and null pointer. List item 1, item 2, item 3. Item 1 dot data is A, item 2 dot data is B, item 3 dot data is C. Item 1 dot link is item 2, item 2 dot link is item 3 dot link is null. Enumerated data types, enum tag name that we will be using is a user defined data type which can take the integer values from the list. These integers values are replaced by meaningful and descriptive names so as to enhance the readability of the program. Descriptive names called enumerator or enumerate constants. Enumerate constant enum tag name. It can be member 1 semicolon to member n. Declare a variable. Enum tag name variable list of identifiers separated by commas. And terminated by semicolon. Terminated by semicolons. That is, it is a user defined data type which can take the integer values from the list. These integer values are replaced by meaningful and descriptive names so as to enhance the readability of the program. Then polynomial. Polynomial is a sum of terms where each term has a form ax bar e. That is, a is a coefficient, x is variable, e is an exponent. The degree of polynomial is the largest exponent of the polynomial or loading exponent of the polynomial. Assume two polynomials, that is sum of ai x bar I, bi x bar I. Then a of x plus b of x is ai plus bi x I. Then a of x dot b of x is equals to sigma of that. An abstract data type. An ADT polynomial is one that shows various operations that can be performed on polynomials. These operations are an ADT polynomial is the one that shows various operations that can be performed on polynomials. These operations are implemented as functions subsequently in the program. ADT polynomial is objects. Functions for all are poly 1, poly 2, polynomials, coefficients, exponents. Then boolean is 0 of polynomial. Polynomial doesn't exist, return true, else return false. Coefficient of poly comma expo. If expo belongs to poly, then return its coefficient, else return 0. Exponent lead x poly, return the largest exponent in the polynomial. Polynomial attach poly coef expo. If expo belongs to poly, then return error, else return the polynomial poly with the term coef expo inserted. Polynomial remove. If expo belongs to poly, return the polynomial with the term whose exponent is expo deleted, else return error. Polynomial add of poly 1, poly 2, return the polynomial poly 1 plus poly 2. Multiplication polynomial 1 into polynomial 2. Algorithm to add two polynomials using ADT polynomials. If lead exp of a equal to lead exp of b, sum equals to coef of a comma lead exp of a. We have polynomial representation. Polynomials can be represented using single dimensional arrays in a C using two methods: using a structure consisting of array, using array of structure. First method, structure consisting of array, struct polynomial int degree coefficient of max degree. Then type def struct int degree coef of max polynomial a comma polynomial b. Here we have 4, 25, then 0, 12, then 2, then 7. Degree is 4, then coef of maximum degree, then coef of max degree. That is there. Then another term, instead of using one array for each polynomial, use one array to store polynomials and use the save space. Each location consists of two fields, that is coefficient and exponent. Two x bar 100, 5x bar 0, then 1 x bar 4, that is there. index of this term, then we will be struct that directing that as define max term 100 type def struct float coef int expo polynomial void poly add. Firstly we have to do this. It is type def struct float coef int expo polynomial p of max term float coef and int expo. So we have polyadd function as polynomial p int start a int end a int start b int end b int start c int end c. Then start c equals to a while start a is less than or equal to end a and start b less than or equal to end b. Switch compare p of start a dot expo comma p of start b dot expo case 0 p of start a dot coef plus p of start b dot coef. If coef not equal to 0, attach coef comma p start a dot expo of p, then start a plus plus start b plus plus break. If 1, then p of start a dot coef start a dot expo dot p start a plus plus break. Thank you for watching. Do like, share and subscribe to my channel.